Hello, this is the third in a series of videos where I'm looking at this GSM module, aka SIM900 module that can be used with Arduino to do various things, and I'll be referring to the previous two videos quite a bit, so you probably want to watch those to follow what's going on. I will put links in the description to those so you can go and check them out. And you'll notice that in this video I don't have my cell phone here, so I'm not going to be doing any SMS stuff. This is purely doing HTTP connections to a web server, and part of what I'm working towards is using a GPS module like that to make a little GPS tracker for my car, I suppose. I don't know if I'll really use it, but it's the making of it that's the fun part for me. So the first part that we need to get organized to work towards that is to get the Arduino to send stuff to the web server. And in my first video in this series, I did it all manually by typing things into the serial monitor. So let's just have a quick recap of how that works. So we have these commands that we need to give to the SIM module, and I'll just bring on a couple of other windows that I have. So the first sketch that I have to show you, or not really to show you, but just to show you what I'm using at the moment, is just this relay sketch, which just takes every byte that we type into the serial monitor and gives it to the SIM module. That's this GPRS, and everything that the SIM module gives to the Arduino will just show on the serial monitor like this. So we should be in the state where we have 80 OK to use that. So that's all we're going to look at for that. But what we need to do is basically this stuff here, and I'm not going to explain these because I explained these in my first video. I'll just remind you though that this Vodafone thing here will probably be different for your case. And these first few lines are some setup stuff. This one shows up as error because I've already done this. Since I've turned the SIM module on, I already did that one. So if you do it a second time, it comes up with error, but that's not a problem. Alright, and likewise I think for this HTTP init one, we'll also see an error, but that's the same thing. That's okay. So these things, basically we just need to fire off a bunch of settings to say which web page we're going to be looking at. So after this we're going to get the Arduino to do this for us. I just want you to see what we're doing manually first, so that it might make a bit more sense when we look at the source code, because this is another video where most of it's going to just be looking at source code. Alright, so this last one here, or second to last one rather, HTTP action equals 0. 0 means get, so we can do a get or a get or a post. And we want to do a get for this URL that we just set. And what happens when we execute this last one is we get some an echo back of that command. So each of these commands, it's just echoing back like this, the command that we typed in. So we can just ignore these echo commands really. But this one, when we execute this, it's going to give us this echo to say that it's received that command. And then we're going to have to wait a little bit for the actual HTTP request to complete. So I'll just click send. So it took a couple of seconds there. So that was the immediate response we got up to this OK. And then we had HTTP action 0234. And I think this is the 0 is the type that we gave it, so that's get, if I remember correctly. Doesn't really matter anyway. And then 200 is the response code, result code, which means it was OK, and then 34 is the length of the data that has been read into the memory of the SIM module for us to access in the next step. So the final step is to use this HTTP read command, and I have 100 here because that's just a number that I had as a default, but in this case we'll be trying to read 34 bytes because that's the length of the data that we have available to look at. Right, so we need to get the Arduino to do this for us, and the first part of it is pretty easy because all we're doing is just firing off these commands one by one, and we don't care about what the result is until we get to this point where we have to wait a bit. We have to wait for something to happen, namely we have to wait for this notification to arrive, plus HTTP action : so we're going to be waiting for the string to come in on the serial connection there, and then we're going to have to look through the next incoming characters, and we're going to have to look for a comma and then another comma, and then after the second comma we'll be able to see this number here, which will tell us the data length, and then we can issue this one. So this is we'll make that 34, and then we'll issue this, and then we'll get another response with the actual content of the web page that we looked up. So this is my test page, which just gives us the current time in GMT. So this is what we need to get the Arduino to do in total. So I'll just get this off of the screen and bring on my source code. Now, as we did with the SMS parsing sketch in the last video, we need to keep track of what state we're in, because we have different states. So in some points we're waiting for a response, in some points we're reading in the result, and so on like that. So how many lines have we got here? We have 180 lines, so it's not super long, don't worry. It's actually shorter than the SMS one, isn't it? So let's look at the states that we could be in. The default state that we start in is detect message type, which means that we are looking for either one of these things here, HTTP action : or HTTP read : so these are the notifications that can be given to us. The next state, or I say next, but it's just the next in this list, it's not necessarily the next in the sequence, is ignoring command echo, and that's just for these lines here, that whenever we give the sim module a command, it will always echo that back to us as a confirmation of what we said. So it's these lines here that begin with AT plus, whenever we see that, we can just ignore everything on the rest of that line. So this state means that we are currently within one of those lines, and we are ignoring everything until we get to the end of line character. Then we have HTTP action type, result, and length. So that's the state that we'll be in immediately after we've detected this colon after the HTTP action marker. So this is the type, the 200 is the result, and then the 34 in this case is the length. So this means that we're going to be looking for either a comma, or a new line character to figure out the contents of those values. And then when we've done that, the next thing is HTTP read length, which is this little bit here. So this is the state that we will be in immediately after we've detected this colon. And then HTTP read content is the state that we'll be in here. So we've detected this colon, we've read in a number, then we've detected a new line, and then whatever follows that up until the next occurrence of a new line. Oh, no, that's not right, is it? We know that it should be 34 bytes long. So when we see that it's 34 bytes, we start reading and we count 34 bytes, and then we know we've finished. So in this case, we're not actually looking for a new line. We're just counting down from 34 until we get to 0. Alright, so hopefully those states should make sense. Now, if you did watch the video that I made yesterday about parsing SMS messages, or reading the contents of SMS messages from the memory card, the rest of this sketch should not be too different from that. So let's have a look at this. So the parse state that we begin in is detecting the message type, that's the default one. And then we have a buffer of characters, and we have a position within that buffer to mark where we are currently. So when the next character comes into we know what position in the buffer to place it into. Then we have a variable called content length, which in this case will be 34 for that particular request. And when the HTTP action notification comes in here and we see this last part of the line, we will set that in this variable there. Then we have a helper function to just reset the buffer, so we fill the buffer with zeros and we reset the position marker to the beginning of the buffer at byte 0. So all that was pretty much the same as the previous video. Now we have something that's a little bit different. So this is we're sending a message to the GSM module. So it's just a character string. So you can see here I've using it like this. So it's just a bunch of messages that we had, the same as in our cheat sheet over there. So I'll just put that over there. So you can see these are all the same inputs. And all we do is we print line each message that we give to this function to the GSM module, and then we loop, and we keep looping while the GSM module is giving us some response. We might not catch everything in this loop, but it doesn't really matter. And usually we do though. And then we'll delay for a certain number of milliseconds, and I've made this to be a default of 500 milliseconds. Occasionally we don't want to delay, we want to do it immediately, and occasionally for one of these commands in particular, this SA excuse me, SABPR, SAPBR, I always get that wrong. SAPBR equals 1,1. Sorry, I still didn't look up what this means. But this one takes a little while to complete, I found, so I used a wait time of 3 seconds for that one to let it finish. It never takes more than 3 seconds for my particular SIM card anyway. And in here, when we are getting some information back from the SIM card, I'm passing every byte that comes back from it into this parse AT text function. So that's almost exactly the same as we had yesterday in the parsing the SIM text. So I've reused most of that function here, but we'll have a look at it later anyway. Alright, so in the setup function, we just do begin and begin for the two serial, well, software serial. This is a software serial connection, and then the hardware serial to the serial monitor is that one, and we just begin those, and then we just throw all of these commands at the SIM module one by one. And so we can see that the very last one here is HTTP action equals 0. So this is going to kick off the actual HTTP request. And then the loop function, all we're doing in here is basically the same as what we had just here. It's a loop that says as long as we have something coming in from the GSM module, we'll pass it to this parse AT text function to do something with. So that's all there is. Now this again is the main part of the sketch, really, this parse AT text function. So we take each incoming byte, and I'll try and skip over this because it's really boring to listen to this explanation, isn't it? And you've probably heard it from my other video. But basically we place it into the buffer, and if the line begins with AT+, we switch into the ignoring command echo state. Otherwise, we check if the buffer contains one of those two strings that we were interested in, namely the HTTP action or HTTP read markers, and we'll switch into the appropriate state for whichever one of those it was. And all the rest of this is pretty much the same as the SMS version, except until we get to... Okay, this starts to be a little bit different here. So we have HTTP action result. So that is when we have just finished reading in that one. Oh, I'm sorry. This is where it starts to be different. HTTP action length. So we've just finished reading in this little bit of text here, and we know that we have reached the end of the line. So this is a new line character we found. Now we can print out that so we can just see what it was, and then we issue the HTTP read 0, comma, and then whatever was in the buffer. So that's going to be this 34 in this case. So we will end up issuing a command like that. Oops. So it'll be like that when we actually issue it. Sorry, there's a mosquito here. Get out. Alright. So then this will kick off the HTTP read request, and so we need to switch it back into the default state and wait for that notification to come. And the next two cases that we could be in are HTTP read length. So when we get this state here is when we have just read this colon, and we're now reading in the 3 and the 4. So we could actually use the 34 there instead of the 34 there to oh, I'm sorry, we are using it. All right. Sorry. So when we get this HTTP read notification, then we know when we get to the next new line character, we've read in this 34. It's going to be the same thing. But I've decided to put it here is the part where I set the value of the content length variable. I thought it might be a little bit safer to do it from this notification than that one, in case you for some reason had multiple requests going and you sort of read in this one and then you missed some data, and then you got another HTTP read for a different result. Then this number 34 would be better to read from the HTTP read notification that it actually arrived with. That doesn't make sense, did it? Never mind. Anyway, so we've decided what the content length is, and we need to keep track of that number, because the next thing we're going to do is read in that number of bytes until we get to the end of the content. So we'll set this to, so in this case it will be set to 34. This is ASCII to integer. And then we switch into the state where we are reading the content. And now this part right at the bottom is a little bit different to what we had yesterday, because yesterday we were doing some processing on the content of the SMS message to turn on or off some LEDs. But for this demo, I'm just showing the content bytes in the serial monitor, which is why I just have this serial write B, and B was the byte that was given to us in the function parameter. So I'm just going to print it out to the serial monitor and we can look at it. That's all we're going to do. But obviously you might want to do something with the content of the message, like put it into another buffer or something, to do something a little bit more interesting with it. And then we're going to decrement that number. So we started with 34 the first time we come in here, then it's going to be 33, and so on, until we get to a point where that number is going to be less than or equal to 0, hopefully just 0. And then we'll know that all of the content bytes have now been read, so we can switch back to the default state and reset the buffer. So this is only going to do one HTTP request, which is why I've called this sketch GSM HTTP get single. So let's upload the sketch and see what it does. Okay, so hopefully if you look at that for a while and sort of let it sink in, it should make sense what it's doing. So I just printed out all of those ignoring echo statements, just so that we could sort of get a sense of how the timing works. And this one at the beginning was the one that I waited 3 seconds for, just to make sure it completed. So nothing interesting happens up until there, which is where we kick off the actual request itself, and then it's just some logging to show us what's going on. So we've split that into the various parts that that message gave us. Alright, so the end goal of everything is this bit here, and that seems to have worked. And like I say, it just does that once, and that's all. So what this program is doing now is it's in the loop function, so it's just going round and round and round in this loop, but the GSM module is not giving us anything because we didn't do any other HTTP requests. I could send a text to it and then we'd see something coming up, but for the purposes of this video we're not going to see anything more here. Excuse me. Alright, so like I say, this is a single version, and for making a GPS tracker we obviously don't want just one message. That wouldn't be very good. We want to continuously be sending messages to the web server. So I've made another sketch here which adds a little bit to this, because we need to keep track of, as well as the state of the parsing state, we need to keep track of whether we are currently in the middle of doing an HTTP request. Because if we are, we don't want to start a new one. So we just have to keep track of a little bit more state. And I did that in this sketch, so I'll put these up on my website. So this one is called HTTP get looped, and I'll just go over the differences. There's not too much. First difference we see is that now we have another set of states to keep track of the action state. So there's just one state at the beginning which we start off, and there's a variable to keep track of it there. So we start off in the idle state, which means we're not doing anything, and there's only one other state which is waiting for a response, which means that we're in the middle of doing a request. So we should not start a new request. And there's one other variable that I've added called last action time, and this keeps track of the last time that something happened. Something meaning either we made a request or the GSM module gave us a byte of data. And we want to use this, or I want to use this in this case, to make sure that we don't I want to send a request every 5 seconds after in a period of inaction of 5 seconds. So I just don't want to flood the server with messages. So that's what that variable's for. Alright, so everything else is the same until we get to the loop. Okay, so now the loop is a bit different. Oh, okay, sorry, there's two things that are different. If I just bring this other one up. Where did that go? This one. Alright, so hopefully you can see that. So we have the setup and the loop there, and over here we have the setup and the loop. There's just one thing that's a bit different in the setup function, and that is that the final line here, which kicks off the actual request, has been moved from the setup function, and now it's in here in the loop function. So that's one slight difference there. Apart from that, though, the setup function is the same. So the loop function has been given this extra little bit of code here. The bit at the bottom is the same as before as well. So let's have a look at this bit of code. We just assign the current time to a variable called now, and then we look and see what action state we're in. And if we are in the state idle, in other words, we're not currently in the middle of a request, we look at how much time has passed since something happened last. And if it has been more than 5 seconds, then we kick off an HTTP GET action, and we set the last action time to now, and then we change the action state into waiting for a response. Hopefully that makes sense. So the next time we come through this loop, because action state is now waiting for a response, this if statement will mean that we don't do this next time. And we will remain not doing it until we set action state back to idle again. So we go right down the bottom of the file, nothing else has changed through here. And then right at the bottom of the file there is this here. So after we've finished reading in the content length and we got to the end of it, we set the action state back to idle so that we can wait for 5 seconds and do another request. And also I put in a series of new line characters so that we can have some space between these sections of requests so that we can tell them apart. So let's upload that and we'll see what that does. So at the beginning we do all that setup, but that's just a once-off thing because it's only in the setup function. Right, so that's one request, and if we just wait for 5 seconds or so, you see another one, and you can see the times on these are changing. So that's 3:12:45, 3:12:53. So what's that? 8 seconds. 3:01, another 8 seconds. So it looks like it takes about 3 seconds or so for the actual request to finish, and then we're waiting for 5 seconds. Oh, we finished in 7 seconds there. That was quick. So yeah, 7 or 8 seconds between requests. So hopefully that makes sense. And one thing that you might want to do, or what I'm going to definitely want to do, is I don't want to be sending the exact same request all the time, because I'm going to want to put on here something like lat equals blah blah blah, and longitude equals something like that. So I'm going to put my latitude and longitude on that I get from the GPS module, and of course instead of putting that in the setup function, we want to put that into here. And it won't be a literal value like this, of course. We'll have to make a value that sets the actual value that we're getting from the GPS like that. So you would want to have this inside your loop function instead. Let me just take that back out. Let me just comment this out. I want to see how fast it can go if we don't do this. Oh, no. Alright, let's see how fast it can go if we don't wait for that 5 seconds in the middle. Yeah, that should be right. So this will give you an idea of how quickly, if you make a GPS tracker, how quickly you can get your tracker to give you position results if it's running at as fast as it can go. So that's 3 seconds, 55, that's 3 seconds again. 2 seconds, 3 seconds. Alright, so yeah, 2 or 3 seconds, at least with this SIM card, SIM module, and with my web server and all that kind of stuff. You know, this particular case, it looks like 2 or 3 seconds is about as fast as it's going to go. That's not too bad really, is it? Okay, well I think that's all I wanted to look at in this video. Like I say, I'll put the sketches up on my website and a link in the description. And if you have any questions, bear in mind I'm not an expert, but I have spent a few hours on this now, so I might have seen something that, if something gives you problems, might be able to help. I don't know. I was going to say something else. No, I can't remember what it was. Anyway, thanks for watching. I'll see you next time.